Hi there. Today we're going to look at some rectangles and solve some proofs and some triangles and solve some proofs. So here's what we know. I'm on page 69. We're going to start on 69. So it says construct rectangle PQR as with diagonals QS and RP. Here's what I know about a rectangle. A rectangle has 90-degree angles or perpendicular sides. And it also has two sets of congruent sides. We also know they're parallel. What I decided I was going to do this was I'm going to use my compass from before, and I am going to extend this line. And I know this is where P is and this is where S is, and I'm decided I'm going to make right angles. And to make right angles, I need a perpendicular bisector. But what I need first is my endpoints. So I'm going to have to make this just a little bit longer. All right, so I know those are the ends of the perpendicular bisector because I know P is the midpoint. Now I made my perpendicular bisector. And here I go. And I'm going to do, it doesn't matter how long you make this, okay? I'm going to do the exact same thing from the other end. So again, I'm going to extend S, and I'm going to make my endpoints because that's my midpoint. One on this side and one on this side. And again, I'm going to have to extend it. So now here I go, more than halfway. 1, 2, and there's my right angle. Trying to set this up. Okay, so there are my right angles. What I also know is it has two sets of congruent sides. So I know these two sides have to be equal. 1, 2. You can make it as tall as you want. I just picked something that where my compass was already set. So now I know I can just connect these. And now I have my rectangle, and I know this side equals this side. I also know this side equals this side because I measured with my compass. Okay, at the bottom of the page, it says we want to prove this. I want to prove that QS, so here's Q, is the exact same size, and I didn't draw well, but that's okay, as RP. So what I'm trying to prove is the two diagonals of the triangles are equal. So I am going to do this one. There's one triangle because I needed something with this diagonal. And I'm going to do this one. And I can choose any of them. It doesn't really matter. I can choose as long as I get my rectangle in, as long as I get two of the sides. Now, because we're all doing it the same way, and again, if you had gone this way, it would have worked too, but you would have just had a different proof. Here's what I know. My given is that PQRS is a rectangle. That's my given. And I also know that this side equals this side, and we just did that. QP is congruent to PS, and I know because definition of a rectangle. I also know that angle Q and angle P are equal to 90 degrees, definition of a rectangle. And finally, I also know, look, I'm using the blue and the green triangle. I know that QP is congruent to QP because of reflexive. Therefore, I know that triangle, I'm starting down this corner, PQR is congruent to, I started with P in this corner, so now S, R, Q, because of, ready, side, angle, side. And if I know that, then I know that QS is congruent to RP because of CPCTC. Okay, and if you need a chance, you can always stop, rewind, and catch up. All right, if you're looking at the back, we can also prove this algebraically. Using the Pythagorean theorem back from algebra, which says a squared plus b squared equals c squared. Okay, again, we're trying to prove the two diagonals. Here's triangle 1 with a diagonal. And here's triangle 2. I'm going to start with the green one. I have x squared plus y squared equals AC squared. Now I'm doing the blue. I have x squared plus y squared equals BD squared. Well, look, I can use transitive. These x squareds are equal. These x squareds are equal. So I now know that a squared has to equal BC squared. Okay, and we know that because of transitive. And these are just Pythagorean theorem. Okay, so now that we've done some rectangles, let's set some triangles. On the next page, it's really the same thing as this one here. It's just a bit bigger. I shrunk it down so you can see it. Here's what I notice. Giving you a chance maybe to look at it. I noticed I had 4 congruent triangles with a pink, a green, and a red side each. See, pink, green, red, pink, green, red, pink, green, red, and the middle, pink, green, red. 1, 2, 3, 4. I also noticed the reds look parallel, and the pinks look parallel, and the greens look parallel. Actually, I don't know for sure. I wonder if the reds, pinks, and greens are parallel. All right, so let's go see what we know. Let's see if that's true. Let's look at the next page. So again, here's my overlapping triangles. Here's what I do know. So this is a bigger one. So let's look at this page and see if it makes sense. Okay, we're going to use your compass and straight edge to draw. I think we should just go back and look at this. Let's go look at this one and see if this works. We know that this, and this are all equal. They're all red. We know that this, and this are equal. And we know this, and this are all equal. So if they're equal triangles. Now, can we know that? We know with SSS they're equal. And if they're equal, we know this angle is congruent to this angle. We know this angle is congruent to this angle, which tells me these are parallel because of corresponding. These are corresponding, which makes the lines parallel. All right, we're skipping page 72 and we're going to 73. So here's when you need your compass again. I'm looking for mine. It says, construct the mid-segment of the triangle below. Mid-segment, not midpoint, mid-segment. A mid-segment is a line segment that joins the midpoints of two sides of a triangle. So here's what we're going to do. We're going to use our compass and straight edge to determine the midpoint of AB and AC. So let's go do AB. To find the midpoint, it's like doing the perpendicular bisector. Well, we don't need the whole line. We just want the actual point. So now I know when I line these up, there's my midpoint. And we're going to call that one X. Okay, same thing for AC. Make it a little bigger. 1. Oh, see, I didn't make it big enough. It's okay. So just erase it if yours isn't big enough. Make sure your compass is possibly a little wider. I didn't go more than halfway. And there's my Y. Now we're going to connect. There we go. This XY is called the mid-segment. It connects the midpoints of two. That's called the mid-segment. Okay, let's compare angle AXY to angle ABC. what do I know? Okay. If I compare these without using a protractor, would you be able to guess the relationship between these two pair of angles? What's the implication of this relationship? Okay, so here's what I know. We already did this. We said on the page before that these were congruent and these were congruent. And we proved that because we said all these triangles are congruent. So what we know now, and these are what we know angle AXY is congruent to angle ABC. We also know this side's congruent. We just did that on the page before. We know that angle AYX is congruent to ACB. And here's what we know. And this is all the things we know about midsegments. And we're going to look back at my picture here. Okay, so let's go back to this one for a minute. We know this, if they're equal, these lines are parallel. So here's what midsegments give us. Okay? They give us parallel lines. Okay? Because corresponding angles are congruent. So see, these are equal. Okay, what else do we know? We also know that, let's compare the red to the red. It's double the size. We know the segment, the mid-segment, is 1/2 the base. Or you could say the base is 2 times the mid-segment. So this tells us lots of things. It tells us these are parallel, and it tells you that this is half of that. It's half of BC. Or we know it's twice XY. And we know that looking at this. 1 red, 2 red. 1 pink, 2 pink. 1 green, 2 green, but it's always based on the base. And that's where I'm ending today. Have a good day. See you all tomorrow or Friday.